Today we're going to start with Unit 6, dealing with circles. So the first question I have for you is, what exactly is a circle? Can you describe it? If you were talking to somebody on a phone and you couldn't use the word circle, could you describe exactly what it is? Most students tell me it's round, but I can draw lots of things that are round. That's round. Is that a circle? And so with a lot of questions and back and forth, I find that most students, they know what a circle is, but they don't really know mathematically what a circle is. So here's a mathematical definition. A circle is a set of points a given distance from another point called the center of the circle. So a circle is really an infinite set of points. And they're all the same distance from a center point. So for example, if I put a point on the board and I gave each student a ruler and they came up one at a time and I said, okay, measure a point that is 4 inches away from my point. And what would happen is that students would come up and they'd take a ruler and they'd measure, and then another student would come up and measure, and then another student, and then another student, and we'd keep going. And eventually, and I'd have people go again and again and again, and eventually what would happen is it would form what we commonly refer to as a circle. Right? Every point on the circle is a fixed distance from the center. And that's the definition of a circle. So let's talk a little bit about segments in a circle. A radius is a segment whose endpoints are the center of the circle and a point that lies on the circle. So one of the endpoints is the center of the circle, and the other endpoint is any one of the points that's on the circle. A chord, which you may not be as familiar with, that's a segment whose endpoints lie on a circle. So both of the endpoints are on the circle. So that would be an example of a chord. Now, there's one special chord, or one special type of chord, that we have a special name for, and that's called a diameter. A diameter is simply a chord that goes through the center of the circle. So not all chords will go through the center, but the ones that do, those are called diameters. So a circle has an infinite number of chords and an infinite number of diameters. Every diameter is a chord, but not every chord is a diameter. That kind of idea we've talked about already with quadrilaterals. We know that a rhombus is a quadrilateral, but not every quadrilateral is a rhombus. So a diameter is a specific type of chord. All right, so those are segments that are special within a circle. So now let's talk about angles and arcs. The first type of angle you should be familiar with is called a central angle. And that's an angle whose vertex is at the center of the circle. So in this example, Q is the center of the circle, and angle PQR, or RQP, is called a central angle. A minor arc is an arc whose measure is the same as the measure of the central angle, and it's always going to be less than 180 degrees. So for example, arc AB, and the notation for an arc is 2 letters with a little curved arc over the top of them. That shouldn't be totally unfamiliar with you. It's kind of like a segment where we wrote 2 letters and then we had a straight segment above them. Now we have an arc above them. And it doesn't matter if you call it arc AB or arc BA. And just like we do with angles, if we want to talk about the measure of an arc, we put a small m in front of it, and the answer is going to be something in degrees. So arcs have a degree measurement. Later on in this unit, we'll talk about the actual length of an arc. Think of that as a piece of string going from A around to B, and then if we took that string and straightened it out, how long would it be? But for now, when we talk about the measure of an arc, we're referring to the measure of the central angle, whose endpoints go to the ends of the arc. A major arc, on the other hand, would be the arc going the other way around, the long way around. So from A to B the other way in the previous example. And that is always going to be more than 180 degrees. So in this example, if I know that, and I don't have a letter for it, so let's call it letter C. If I know that angle DCF is 150 degrees, then I know the measure of arc DF is also going to be 150 degrees. So when I just have two letters for an arc, that means the shortest distance from one to the other. So from D to F or from F back to D, the shorter distance. The longer distance from D through another point E over to F, that's called a major arc. And since the entire circle we know is 360 degrees, the measure of the major arc is going to be 360 minus the measure of the minor arc. So we get 210 degrees in this case. Also notice the notation for a major arc, we have to use three letters. So we have to have D and F, doesn't matter the order of those two, but there should be a letter in between them. So any point along that major arc we can use, so we need three letters. If you only see two letters, you know they're referring to the shorter distance around the circle. And finally, we have a semicircle, which is exactly half of the circle. And so the measure of a semicircle is 180 degrees. The angle is actually the diameter of the circle. So both of these arcs are 180 degrees. So we have segments associated with circles. We have a radius, a chord, and a diameter. And then we have angles and arcs associated with a circle. A central angle with the minor arc and the major arc in the semicircle. And one other important angle is called the inscribed angle. And that's an angle whose vertex is on the circle. In this case, point E is on the circle. So angle CED, or DEC, is called an inscribed angle. So at this point, it's a good time to break and look at a GeoGebra example to see if we can find some relationships between these arcs and angles.